X-intercept, for example, 3. There is no x-intercept, so don't write 0. That would mean that there is an x-intercept where x equals 0. Instead, we're going to put none or NA. We have one y-intercept of 0, 2. Remember, one y-intercept of 0, 2. Remember that functions have at most one y-intercept. Let's do the domain. So I'm standing here, I'm looking up and down, and if I look way down below, I can see the function. I eventually would see it. And I walk, I can see it, and I'm walking on the X bridge, and I can see it. Even way over here, even over at 10, I eventually would be able to see this function, negative infinity to positive. So I'm going to extend this down. This is negative 10. I'm going to do a 90-degree turn. I know that for most students, this is one of the most difficult things is being able to precisely identify the range. So I'm going to stand on negative 10 and look up, and I would see the function. And even if I was at negative 20, I could see the function. So I'm going to go from left to right, negative 5, yes, keep going. When's the last time I need to stop? I stop at negative 1, and do I see anything at negative 1? Most people say yes, you see something, but is a circle considered a point? Good job. So we're going to say negative infinity to negative 1, and we don't see a point there, so we put a parenthesis. Then I'm going to rotate back so I can see. I start walking, and when's the next time I stop? At 2, and there's points there. So at 2, come back again, and I start walking, and the next time I see a point is at when x equals 5, and there is an actual point there, and as I move to the right, I continue to see a point. So from 5, moving to the right, there would be points. Sorry? Let me move this off to the side. Now another way to look at that, you may also look at range. Take your pencil or pen, please don't talk when I'm talking. Take your pencil or pen, and I want you to put it down below. Another way to read this is if for range is describing the y's, you can go as low as you want. Would you agree that this line will actually connect with you at some point? Yes? And you can keep coming up all the way up to negative 1. And when you get to negative 1, is there actually a point at negative 1? No, it's an open circle. When's the next time we see any part of the graph? When y is 2, true. Then we go up to y is 5, good, and we see an actual point because it has a bracket, and as we move up, we continue to see points on the graph. Okay, let's do mapping. I go to 1, 1 maps onto 2. I go to negative 3 maps onto 2. I go to 4, 4 maps onto 8. If you see me make a mistake, please let me know. Okay, let's go down below. I'm going to start with doing increasing, decreasing, and constant. Off to the side, please write x values as a reminder. We are going to describe this in terms of x values, and these bottom 3 will always be in parentheses. Increasing from left to right, this is going up, so it's increasing. From left to right, this is flat or parallel to the x-axis, constant. And left to right, you're going up again or increasing. There is no portion here of this piecewise graph that is decreasing. So I go to decreasing, and I say there is none available. Okay, I'm going to slow it down. How do we describe increasing? So for this portion, in terms of x values, it comes from left to right. This entire part is increasing from left to right. So from left all the way to an x value of negative 3, it is increasing. Then it's increasing from 2 all the way to the right. So from 2 to positive infinity, it is increasing. When you leave 2, you start to increase as you move to the right. Okay, let's go with the constant. From negative 3 to positive 2, in between negative 3 and positive 2, you are constant or flat. Please go on the x-axis and make these wiggly lines. And this time I'm not going to shade it in, but I am going to identify where is it positive and where is it negative. You don't have to do that. I just think for students who may struggle, it just makes it a little bit easier. So how do we precisely identify the intervals that are positive? Well, let's look at just the x values. So it's positive from negative 3 to 2. Okay, negative 3 to 2. Now I have to analyze the endpoints. At negative 3, it's a closed dot, and it's above the x-axis. All of these have positive y values. So this has a positive y value. I have to include it when I'm asked where are the y values positive. 2 has an open circle, so there's not a positive y value within an open circle. There's not an actual point in the positive region when x is 2 at this part of the interval. Okay, let's do the second part of the interval. When we start at x equals 2 above, we have a closed dot, and it is in the y portion that's positive. And as we move to the right in terms of x values, as we move to the right, this entire piece of the function is positive. Where is it negative? Down here in terms of x values, as you come from the far left-hand side and you approach an x value of -3. Now at -3 we have an open circle just like we had over here. So this would not be considered negative even though it's down below. Go down below and please write end behavior. Okay, ready? As I go to on the x-axis, the far left-hand side, x-axis, far left-hand side, I want to describe the behavior of the y's. When this piece of the function enters into this region, which way is it going? Down or decreasing? Going to negative infinity. As we go on the x-axis, the far positive side, when this enters in, which way is it going? Flip your paper over to the back.